Alrighty, welcome to College Prep, Unit 6 notes. Unit 6 is all about factoring. We're going to start with 6.1 here, greatest common factor and factoring by grouping. Now, before we do anything though, let's define what we mean by factoring, okay? So let's define what does it mean to factor? Well, factoring takes a polynomial and it undoes the multiplication. Now notice here it doesn't say it divides. It's not the opposite of multiplication, right? Because the opposite of multiplication would be division. And though we use division a lot in the concept, it's really undoing the multiplication. So if you take a look down here, we've got stuff like 3x times 5x minus 2. We end up getting 15x squared minus 6x, right? So we distribute it in, and that's what you get. That would be multiplying. Okay, so that's multiplying polynomials. The second example you see here is the same thing, but notice it's written backwards. This one is where you take a polynomial, such like that, this binomial here, and you pull out what they have in common. Essentially, you get back to where you started, that 3x times 1. This is called factoring. That's the factoring. So factoring essentially undoes the multiplication as far as you can go. It breaks it down into factors. Remember, a factor, like the factors of 8, factors for numbers are anything that multiplies together to get that number. So the factors of 8 would be 1 and 8 and 2 and 4, right? So if you're breaking things down, that's pretty easy for numbers because you know what multiplies to 8. However, when you break down polynomials, it takes just a little bit more of a step. Okay. Now what we did here, the second pink example here, that's what we call greatest common factor. Okay, so that's the biggest thing that they had in common. That's what we're going to do in Objective 1 here. We're going to take a look at some polynomials. So polynomials, and we're going to find what they have in common. What's the biggest thing they have in common? Whether it's a variable, a number, or a coefficient, or both. We're going to find out what they have in common throughout their terms, and we're going to take it out. That's the idea. So we're going to find biggest, let's call it greatest because, that's what it is. So find the largest or the greatest, right, thing they have in common. So common factor, and their factor are the things that they can be multiplied by. So really, once again, this name is not trying to trick you. It's trying to show you exactly what it is. The GCF is the largest thing they have in common, the greatest common factor. Once you find it, we're going to take it out. Take out. Okay, so this is what it kind of looks like. We've got this polynomial here, this binomial, 8x plus 12. I noticed that, well, the first term has an x, the second term does not have an x. So there's no way that they could have an x in common, right? And when I say they, I mean the terms. There's no way the terms have an x in common. Okay, so that's not part of the GCF. GCF has no x, but they do have a number in common. They have a factor in common. If I look at the factors of 8, well, I already did that up here, right? 1, 2, 4, and 8. And then I also look at the factors of 12, 1 and 12, 2 and 6, 3 and 4. I notice that they have a 4 in common, right? And that's the biggest thing they have in common. They also have a 2 and they also have a 1, but the greatest thing they have in common is a 4. And so I can take the 4 out. So their GCF is 4, right? Once I find their GCF, I can remove it, or essentially divide by it from each time. So in the first term, I change 8x to 4 times 2x. In the second term, I change 12 to 4 times 3. Then, this is the trick, well, not really the tricky part, but this is the important part. We're going to use distribution property in reverse. So we're going to take it out instead of distributing it in, and we end up with 4 times 2x plus 3, and we have factored. So that's the idea. If we had gone backwards, right, if somebody had given us this is the original problem, then we would distribute it in and combined to get 8x plus 12. So we're undoing the multiplication here. All right, let's try this again with one down here. I've got 9z minus 18. 9z minus 18. So I'm going to look at these two separately. 9z and 18. I'm going to ignore the negative one for just a minute. 9z and 18. Let's take a look at what we have in common here. Well, 9z is 3 times 3, right? Or 1 times 9, right? And it has a z. Cool. What I've just done here is called prime factorization. I basically broke it down until I couldn't break it down anymore, so I broke it down into primes. This is like one method you can do. 18 I can break down into 9 and 2, which is 2 times 3 times 3, right? So this here was 9, and that was the 2, right? 9 times 2 is 18, or in other words, it's 2 times 3 times 3. And then I look at what they have in common. 3 and 3. Okay, so their GCF will be 3. This is called the prime factorization method. It can be the quickest, especially with those larger numbers and you don't want to write out all the factors. However, there is a second method. We can just look at the factors. So if I look at 9z, I can say, okay, there's 1 and 9, and there's 3 and 3, right? And then they also have a z in common, or it also has a z, right? So those are all the factors, 1 and 9, 3 and 3, it's also got a z. Then I look at 18, I can say 1 and 18, 2 and 9, 3 and 6. Okay, well, looks like the biggest thing they have in common is a 9, and that's all they have for that. They don't have any variables in common. So their GCF, oops, I'm so sorry, I meant to write 9 here, not 3. JK, LOL. Oops, pink. Right, because they had 3 and 3, that's 3 times 3 is 9. So their GCF over here would be also 9. Either way, you end up with the GCF, the greatest thing they have in common. Again, I prefer the pink method because you can just keep circling stuff. But here, if you'd like to write out all the factors like we did in the first one, you can do that as well. Once we've found the GCF, we need to take it out. So I'm going to go over here. I'm going to say, okay, my original thing is 9z minus 18. That's my original polynomial. And I'm going to divide by the GCF to each term. Divide by 9. When I do that, I'm essentially taking it out. So instead of multiplying a 9 in, I'm pulling a 9 out. That's what I'm doing, right? But in order to do that, I have to divide. When I divide 9z by 9, those two cancel. I'm just left with z and a minus sign. 18 divided by 9 is 2, and I have factored 9 times z minus 2. There is my final factored form. Awesome. Let's try it again. 56m plus 35p. Let's try that now. Let's take a look at them individually. 56m and 35p. Now again, you could list out all of the different factors of 56 and 35, but 56 has quite a few factors. So I'm going to list out its prime factorization. I'm going to take it down to all primes, make it a string of 2 times 3 times 5 times 7, all the primes, the things that don't break down into anything more. So that would start with a 2, because it's even, right? So I have a 2 times, well, 2 times 28 is 56, so now I have to break down 28, because that's not prime. So 28, I'll do it up here. So I have 56, breaks down into 2 and 28. 28 breaks down into 2 and 14, and then we all know it's 7 and 2. So 2 times 2 times 2 times 7. And I bet you if you plug that back into a calculator, you would definitely find that that equals 56. And then they also have an m, or it also has an m. The term also has an m. I'll do the same thing for 35. 35 is a little easier because it already breaks down into primes when I go 5 times 7, right? You've got a p as well. Fantastic. So those are the prime factorizations. Now I will go circle what they have in common. Well, 35 doesn't have any 2's, which brings a lot out. 56 doesn't have any 5's. They do share a 7, and one has an m and one has a p. So it looks like they don't have a lot in common, but they do have something in common. Their GCF is 7. Now notice I wasn't expecting anything to be in common, right? I didn't say it had to have a number, it had to have a variable, it had to have this, had to have that. Greatest common factors don't need to be anything. They don't have to have a certain form. They could be a number, they could be a variable, or they could be both. It's what is in common, okay? It's not supposed to end up that way, or end up a certain way. It's just supposed to be whatever they do have in common. So now let's take whatever they have in common, that's 7, out of the original polynomial. So my original polynomial is 56m plus 35p, and I will now divide by my GCF. Divide by 7. And I'm left with, the 7 doesn't go away, it just goes on the outside. And let's see, 56 divided by 7, it's going to be 8 plus, oops, I'm so sorry, 8, and then I still have the m on there. And then 35 divided by 7, that's going to be 5p. And I am finished. Awesome. It's important to note that if I was wondering whether I was truly finished or not, I could look inside the parentheses. If there was anything else those guys had in common, I did not actually find the GCF. I found a common factor, but I didn't find the greatest common factor. So watch out. For example, in the last problem, if I only took out a 3, then they would still have another 3 in common, right? Because they actually have 9 in common. 9 is the greatest common factor. So if you take out a lower number, then what's inside your parentheses will still have more to take out. Okay. Example C. 2y plus 5. Well, let's see. 2y and 5. Let's break it down. Okay, well, 2 is a prime, so I can just write 2. And y is a variable, so we'll just write y. Fabulous. 5 is also a prime. Interesting. Looks like they don't have anything in common, right? So what would we call the GCF? There is always a GCF. Oops, horrible writing. Sorry. There is always a GCF every single time. What is that something they do have in common? Well, it's definitely not 2, it's not y, it's not 5. But remember, lazy mathematicians never write 1. You can always multiply things by 1. Us lazy mathematicians just don't like to write things that are unnecessary. So, they have a 1 in common. They still have a 1 in common. Therefore, their GCF is 1. So if they have nothing else visible in common, right, no 7, no 9, nothing they have in common, then their GCF is equal to 1. And when you take 1 out of something, you divide everything by 1, you are left with the original thing, right? So if we were to take 2y plus 5, divide them both by 1, nothing would change, and we'd end up with the same polynomial times by 1. This is what we call a prime polynomial, right? Because its only factors are 1 in itself. That's what a prime means, right? So it's a prime polynomial. And they happen sometimes. That's a great way to check that you're done, right? Like this one right here, he's a prime polynomial. Z minus 2, that's a prime polynomial because the only thing they have in common is 1. Alrighty, let's try something a little harder. Let's keep going. 9x squared plus 12x cubed. Alright, I'm going to take a look at these individually. 9x squared factors down into, well, 9's not prime because it's 3 times 3, but 3 and 3 are both prime, so that's okay. Now let's take a look at that x. X, I have x squared, which means I have 2 x's. I'm going to break that down as well. Okay, so I'm not going to leave it as x squared. I'm going to break it down into x times x, because that's the definition. Essentially, that is a prime factorization, quote unquote, of a variable. So that's kind of how you break it down for prime factorization. Let's do the same thing for 12x cubed. Well, 12 is 3 times 4. 3 is a prime, but 4 is not. So 3, let's see, 4 breaks down into 2 times 2. So let's do 2 times 2 times 3. That's the prime factorization of 12, and I have 3 x's. Sweet. Now I will find out what they have in common. So it looks like, well, 9 doesn't have any 2's in it. It's not 2, but they do share 3. And it looks like they're sharing an x, and they're sharing another x. Awesome. They have a 3, an x, and an x in common. So their GCF is going to be 3xx or 3x squared. That's the biggest thing they have in common. A 3 and 2 x's. Now I will do the same exact thing. I'll divide it out. And if I had 9x squared and 12x cubed to begin with, I can divide it by 3x squared and 3x squared. And what I'm left with, remember that 3x squared doesn't go away. It goes on the outside. It's your first part of your factors, right? So make sure you always include that first part of your factor. But then when I divide it, well, those two are going to cancel, right? Quotient property, or quotient rule, right? So x on the top, x on the bottom, cancel. 9 divided by 3 is 3. Same thing over here. Quotient rule says I've got 3 on the top, 2 on the bottom. I'm left with 1 on the top. 12 divided by 3 is 4. So 3 plus 4x times 3x squared is my final factored form. And I can tell that because these guys don't have anything in common, right? Fabulous. All right, so we've been dealing with a lot of binomials, right? We saw one with now that has or just notice first before we move on, that this one had something in common when it came to the variables. Up until now, we didn't have anything else in common when it came to the variables. Remember that GCF doesn't have to have anything. You don't even have to have a coefficient. The thing they have in common could very well be just the variable, but it just depends on what they do have in common. Your job is not to make it look a certain way, it's to find what they have in common. That's your job. Alrighty. Like I said, up until now we've been dealing with binomials. Let's try a trinomial now, 3 terms, right? But the process is the same. Let's just look at all the terms and see what they have in common. Let's see what they have in common. So let's start with 32p to the 4th. Well, 32 breaks down into 4 and 8, but neither one of those is actually prime. So we'll break 4 down into 2 and 2. 8 breaks down into 4 and 2, or 2 and 2 and 2. So 2 and 2 and 2. So that would be 4 times 8, 32. And then I've also got 4 p's. Alright, cool. There's the prime factorization of 32. 32p to the 4th. Now let's do, what's the next one? 24p to the 3rd. I'm saying negative 24p to the 3rd. Let's see, 24 breaks down, well, I've got, okay. First off, let's deal with this negative. When I have a negative like that, I like to leave it in. Some people ignore it, which is fine, but I like to see if they have negatives in common. So I'm going to say this is first off multiplied by a negative 1, and then I'm going to do the factors of 24. You see how that worked? I kind of pulled out the negative 1, just like I pulled out all the 2's. Now I'll break down positive 24 because that's going to be a lot easier. 24 breaks down into 3 and 8. Well, 3 is prime, but 8 we just saw is 2 times 2 times 2. And then I have 3 p's. P, P, P. Alrighty, one more, and I'm going to try and squeeze it in there. 41. 41 p to the 5th. Okay, 41 is actually prime, so its only factor is 41. But it's got 5 p's. P, P, P. 5 p's in common. Okay, cool. That one was a little easier. 41 is actually prime. Now, if you didn't know that off the top of the bat, that's okay. Start by dividing by 2. Well, you can't because it's odd. Then divide by 3. Well, you can't because it ends up being 13.66666, right? Then divide by 4, divide by 5, divide by 6. Get all the way up to 9, and then your chances are, if you get up to 9, or sorry, if you get up to 9 and you haven't found anything, chances are it's probably prime. I'm not going to say it's definitely because I know as soon as I say that, somebody's going to go find the one that only works for like 13 or something. But in this class, if you get up to 9 and there's nothing that divides into it, it's probably prime itself. Okay? It's probably prime. Alrighty, let's take a look at what they have in common now. This is very, very important though. When I'm looking at what they have in common, it has to be common to every single term, okay? Whole span across the board. Everybody's got to play. I can't just find things in common between blue and red. I have to find anything in common between blue, red, and green, okay? So if I look closely, I might be tempted to say they have a lot of 2's in common, right? But green doesn't have any 2's, so there are no 2's in common. There's no 3's in common. There's no negative 1's in common. There are a few p's in common, so we can start with those, but they actually have no numbers in common, no coefficients at all. Let's take a look at those p, though. They've got 1, and 2, and let's see, 3, and I've run out of p's here, so it's got to be 3 in common. So their GCF is a simple p cubed. That's it. Remember what I just said in the last problem. Sometimes you don't have a coefficient. That's okay. That's just what they have in common. That's all it is. Now I will do the same thing we did with the binomial. I'll take my original polynomial, right? So 32p to the 4th minus 24p cubed plus 41p to the 5th. And I'll divide it by p cubed, like GCF. Divide each one by p cubed. And the p cubed, remember, doesn't go away. It goes on the outside. But I'm left with 32p minus 24 plus 41p squared. Right? So the only things that are going to cancel are these p's. And I'm left with this factored polynomial. Oops. Awesome. Now, you may have noticed that what is left over here is going to be what's left over there. If you notice that, that's okay. Feel free to skip this step. But I always like to divide by the GCF because then I know if I actually got something right, okay? So I always like to keep this step. But if you can see that these 5 2's remain, and therefore, these 5 2's and a p remain, and if you stick them back together, you get 32p, you're welcome to do it that way as well. Alrighty, let's try another one. I'm going to erase these little p's right here just a little bit so that we can see the problem. We've got 3k to the 4th minus 15k to the 7th plus 24k to the 9th. Now at this point, this is no longer a sub video, so I'm just going to keep going. But if you ever want to try this yourself, make sure you stop the video. Okay, so stop the video and give it a try. Then you can see if you're actually getting it, right? Staring at this is probably not helping you. If you don't try it on your own, you're never going to get it. So let's break it down. We got 3k to the 4th minus 15k to the 7th and 24k to the 9th. Okay, luckily 3 is already prime, so that just breaks down to 3. And I have 4k's. The 15 was negative, so I'll start by making it a positive by taking out the negative 1. And 15 breaks into 3 and 5, both prime, so I don't have to do it anymore. And I've got 7k's. 1, 2, 3, 4, 5, 6, 7. 24 breaks down into 3 times 8, but we know that A is not prime, or 8 is not prime, so it's 2 times 2 times 2. And I think I'm going to write it in numerical order just to make sure, whoops, I get everything. 2 times 2 times 2 times 3. And then I've got 9k's. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, cool. Next step, find out what they have in common. Well, they seem to have a 3 in common and no other numbers, and they've got 1, 2, 3, 4k's in common. Yep, 4k's in common. So the GCF is 3k to the 4th. Alright, notice that took a lot of room, right? That took a lot of room. If you can do this part, the prime factorization in your head, then that's awesome. You're going to save yourself a lot of room and a lot of time. But until then, try writing it out. Okay, if you're watching this video because you need extra help, you definitely need to write it out. Okay, so write it all out and make sure you can circle everything they have in common. If you can automatically see, though, that 3, 15, and 24 all have a 3 in common, then you're fine. And the K's, they have at max 4 in common, you can take those out, right, and save yourself some room. Room is not important in math, though. We can always get more paper, so it's fine. Make sure you know how the process works. Alright, so when I take out 3k to the 4th, I am left with, ooh, we'll come back to this first term. The second one, I am left with negative 5k to the 3rd and a positive 8k to the 6th. Okay. Now this first term, what am I supposed to write there when the whole thing comes out? That's a very interesting question. Well, remember, if the whole thing gets used, there's still an invisible 1. So here, it's 1 times k to the 4th, and what's left over when you take out k to the 4th? The 1. So watch out for that. If you start with a trinomial, you should end with a trinomial. If you start with a binomial, you should end with a binomial. Alright, so everything should be the same. And I'm going to rewrite this because it's not a lot of room. So we ended up getting 1 minus 5k to the 3rd plus 8k to the 9th? No. Took out 4 of 9, that's 5. Yeah, we took out 4. Sorry, not 6. K to the 5th. There we go. And that's our final factored form. Awesome. Let's do another one. 24m cubed n squared minus 18m squared n plus 6m to the 4th n cubed. Wow, that's a lot of variables. Doesn't matter though, right? I'm just going to break it down piece by piece, and I'm just going to find out what they have in common, right? Greatest common factor. So 24m cubed n squared. Let's take a look at that one. That would be, well, we've broken down 24 a few times now, so 2 times 2 times 2 times 3. I have 3 m's and 2 n's. Then I've got negative 18 Negative 18m squared n. Well, negative 18 becomes positive by negative 1, right? Want to take out that negative part. 18 breaks into 2 and 9, or 2 times 3 times 3. And I've got 2 m's and 1 n. Lastly, I have 6 m to the 4th, n to the 3rd, which would be 2 times 3, m, n, n. Next we go with circling. Yay! Okay. They have a 2 in common. Oops. Let's do this. They have a 2 in common. And they have a 3 in common. They have, looks like, 2 m's in common. And 1 n in common. So the GCF would be 2 and a 3 and an m and an m and an n, otherwise known as 6m squared n. Notice this one had multiple variables. That's cool. Again, not supposed to look like anything, so that's just a fun fact. When we take that out though, 6m squared n becomes, let's see, 24m cubed n. Take away 6m squared n, that leaves me a 2, an m, and an n. 2mn. Oh, no, sorry. 2 2's. Just kidding. That should be a 4. 4mn plus, see what's left over here is a negative 1 and a 3, and that's it. So I take out a negative 1 and a 3, I get negative 3. And my last term, let's see what was left over. Let's see, I took out the whole 6, right? And then I've got 2 m's and an n left over. So m squared n. And I found my final factored form. Fabuloso. Let's do one more together just to really drive it home. 25x squared y cubed. And then I've got 20 y to the 5th. And negative 15x to the 4th y to the 7th. They want me to find the GCF of each one of these. Right, GCF of each one of these. We'll break it down. 25 is 5 times 5. I've got 2 x's, and those are both prime, so I can leave it at that. Y. 4 times 5. Oops, I don't want to write 4 because 4 is not prime, right? I want to do 2 times 2 times 5. Y, and y. 5 y's. A negative 1 to make it positive. 15 is 3 and 5. Then I've got 4 x's, 3 and 4, and 7 y's. 1, 2, 3, 4, 5, 6, 7. Alright, let's take a look at what they have in common. Well, they don't have a negative 1 in common. Don't have a 2, don't have a 3, but they do have a 5. Alrighty. Ooh, x's, I gotta be careful. The first one has x's, the third one has x's, but this one doesn't have any x's. There's no x's in common because the second term does not have any x's, right? But it looks like they have 3 y's in common. So I'm bypassing all the x's. They don't have any x's in common. So the GCF would be a humble 5y cubed. So notice, it didn't have to have an x, right? Just because it had multiple variables in the polynomial doesn't mean that that's going to be something they have in common. It's what do they have in common, not what are they supposed to have in common, okay? All right, we factor it out. 5y cubed, so it goes on the outside. What's left over is a 5, an x, and an x, so 5x squared, plus 2, yy, that's 4y cubed. Sorry, 4y squared. And if I look at that, if I go back and I say, okay, that divided by 5y squared would also give me 5x squared. So that's what I'm doing. I'm looking at what's left over, but I'm also dividing. That's what I'm doing. I'm dividing out what I know to be in common. So I'm dividing this out, and I'm dividing that out, right? The 5y cubed. What's left over is the 4y squared. And then the last one, negative 1 times 3, that would be negative 3. And I have 4 x's and 3 y's, so x to the 4th, y to the 3rd. Oops. Oh, so sorry, so sorry. There we go. And there's my final factored form. Okay. So hopefully by now this is making a lot of sense. It's just pulling out what they have in common. We can extend this idea a little bit if we to things that aren't exactly polynomials, right? They aren't exactly polynomials. But this sort of thinking down here is a great way to think about stuff if you're going into computers. Until then, though, if you haven't gotten this down quite yet and you're at home, you need to email me as fast as you possibly can, because this GCF, the entire rest of the chapter is based off of it. I'm going to say that again. The entire rest of the chapter is based around greatest common factor. So if this is not making sense to you, then you need to email me as fast as possible and we'll get this figured out, okay? Okay, so let's go on to the next ones. Let's take a look at this thing and we'll apply the logic of GCF. So we're going to factor using a GCF. Now obviously this is not a polynomial, right? As it is. This is a binomial times a binomial plus a binomial times a binomial, right? It's broken down. But we can use the idea of GCF, and we're going to use this a lot, especially when we get to grouping in just a moment. But let's look at this, and let's pretend that these are both the prime factorizations. Let's pretend. So in this first one, I have x minus 6 and 2x plus 5. Let's consider this the same thing as 2 times x, or something like that. In the second one, I have x minus 6 and 2x plus 6, right? Considering that, what do they have in common? They have this in common, right? They have the first parentheses in common. That's what they have in common, right? Remember, GCF doesn't have to look like anything. In this case, it looks like an entire parentheses. So their GCF is x minus 6, a whole binomial. And that's okay. That's okay. Remember, we're kind of using the logic here. I know if it's not really a factor. I mean, well, it is a factor. I take that back. It is a factor. It's definitely the greatest thing they have in common, though, right? So if we take that out, x minus 6, what's left over would be 2x plus 5, right? And it would be added to 2x plus 6. Now we could combine those. Right, we definitely should combine those. We end up getting x minus 6 times, let's see, 4x plus 11. Right, combining like terms, 2x, 5, and 6. And that would be our final factored form. And it would be awesome, and we would be done. So, but the main point here is that the GCF is now a parentheses. It's a parentheses. Something they have in common is an entire binomial, right? And we're going to use this in like 10 seconds we step to grouping. So let's practice it one more time using this idea of a GCF as a parentheses. What do these two things have in common? Well, if you look closely, they don't have a p plus 2 in common, right? They don't have a p3, p plus 4 in common, so it's neither one of those. What they do have in common is a p minus 5. If we kind of think of this as two separate terms, right? P minus 5 is what they have in common. So we'll take that out. P minus 5. What's left over is a p plus 2 minus a 3p plus 4. Notice now I'm very tentative about keeping those parentheses, right? Because it's subtracting. In our last chapter, we talked about what happens when we subtract polynomials, right? We got to distribute. So this becomes p minus 5 times p plus 2 minus 3p minus 4, right? And we distribute that out. And we end up with p minus 5 times, let's see, p minus 3p, it's going to give me a negative 2p plus, 2 minus 4 is going to give me a negative 2. And there is my final factored form. Okay? Alrighty, so that's essentially the idea of using GCF on parentheses. There's one other thing you can see in GCF. It's sort of just a helpful hint. Or not really a helpful hint, but a helpful step. It's not required by any means necessary, but if you have a trinomial such as this, let's take a look at what they have in common. So we've got negative a cubed, that would be negative 1 times a times a times a. and 3a squared, right? Would be 3 times a times a. And then you've got negative 5a, which would be negative 1 times 5 times a. Alright, so now as we've been doing this, right, definitely same thing, same process, right? What do they have in common? Well, they have an a in common, definitely. And it looks like that's all they have in common. So one could argue that their GCF is in fact a. However, I'm noticing that there's a lot of negatives here, so I'm going to take out a negative 1. You may be thinking, Miss K, that's illegal. The second one doesn't have a negative 1. You're absolutely right. You're absolutely right, except you're wrong. Remember, 1s and negative 1s, they're always there. The 1 is always there. I still have here a factor of 1. We'll call it this factor of 1 right here. Let's not use that color because you can't see it. Let's do an extra factor of 1. And if I rewrite that as negative 1 times negative 1, then they do have a negative 1 in common. You see what I'm saying? So it's just a tricky step. Again, you don't ever have to do this unless you think it would be necessary, right? Normally when I see a negative out front here, I kind of think of this. That's kind of my key to look at, maybe I should take out a negative from all of these. So now they do have a negative in common, which changes my GCF to negative 1 times a, or negative a. And I think I'm going to take that out. You can always take out a negative 1. You can always take out a 1, okay? And when I do that, then I get negative a times a squared minus 3a, minus 3a plus 5. That's what's left over. And that would be my final factored form. Now, if you had just taken out a, right, it was a question on the test, they wanted you to factor this, you just took out a, by no means would you be wrong. So there's a secondary answer that says a negative a squared plus 3a minus 5. That's by no means incorrect, because what they had in common was a, and you're absolutely right. But when you have a negative in front of that, it's going to help you, especially later in the chapter, to take out that negative. So I would just always take out a negative when you see a negative in front. Alrighty, so that was factoring by grouping. I'm sorry, that was factoring by using GCF. Let's go on to factoring by grouping now. Factoring by grouping is essentially what we've just done in example 1.3, okay? So it's getting down to something like this so that you can take out a GCF. So essentially factoring by grouping, how I like to think of it, grouping is GCF 3 times. GCF 3 times. That's all it is. It's GCF 3 times. Notice, remember when I said this is the most important chapter and you're going to use it the rest of the chapter? Yeah, I wasn't kidding. It's GCF 3 times in a row. Okay? So, let's take a look at this thing. This thing is AX minus AY plus BX minus BY. A lot of variables, no coefficients, and that's okay. No big deal. Let's take a look at it, just GCF across the board. Well, there's an A and an X, an A and a Y, a B and an X, and a B and a Y. Doesn't look like they have anything common in all 4 terms. Okay. Not all hope is lost, though, because we're going to break it down into groups. Hence grouping. So we'll group the first 2, oops, and we'll group the second 2. I made 2 groups. Now I'm going to look at GCF individually. So this first one, let's just look at this first one. Let's pretend the second one doesn't even exist. I'll do it in, I don't know, orange. AX and AY. What do they have in common? Well, that's an A times an X and an A times a Y. What do they have in common? They have an A in common. Alright, so this one, the GCF is A. That was my first time doing GCF. Check. Now I'll go ahead and take it out. So down here I have A. What's left over is X minus Y. You know what? I'm not going to write it there. Just kidding. I'm going to write it over here. A times X minus Y. Right? That was the first group. Now I'm going to do the exact same thing for the second group. I have BX, which is a B times an X, and a B times a Y. I'm so sorry, we should have had a negative in there, but as you saw, it doesn't really matter. So negative. So negative 1 times B times Y, right? What they have in common? That would be a B. Take out the B. Oops. Oops. So their GCF is a B. Alright. Take out plus B. Positive B. What's left over is X minus Y. Now this time I chose to leave the negative in because I want these two to match. So that was the first time GCF, second time GCF. Now I have this thing, right? And that thing looks an awful lot like this, right? It looks an awful lot like they have a parentheses in common. They have a GCF of x minus y, right? That's what they have in common. And that's why we practice those other ones. So this is their third time. So we had once, twice. Now we're going to take out this thing they have in common. And once we do that, what's left over is a plus b. And we are done. We have factored by grouping. They no longer have anything in common, and we are done. Alright, let's try it again. Something very similar, right? So we can make two groups. Right, we have 3x and 3y, negative 3y. So we got 3 times x, negative 3, oh I'm so sorry, not negative 3. Negative 1 times 3 times y. What they have in common is a positive 3. So we'll take out a 3 and we're left with, let's see, x minus y. Same thing goes for the other group. Right, I have negative a, I'm sorry, no I don't, I have positive a, x, and negative ay. What's left in common? So ax, negative 1 times a times y. What they have in common is the a. So I have a times x minus y. Put them back together with plus sign, right? Then take out what they have in common a third time, the x minus y. So 3 plus a times x minus y, and we have our final factored form. Almost virtually identical to the last problem, but I just wanted to show you it works with coefficients of numbers too. So it doesn't work on just variables, it works on coefficients with numbers. Okay, so that's essentially factored by grouping. It's GCF 3 times. Let's try it out with some few more complicated things. Alright, and here's some more broken down steps for you. But I just like to think of it as once, twice, 3 times. That way I just know I'm doing GCF. The same thing I did for like the last 20 minutes. Over and over and over again. That's all I'm doing. Alright, I'm going to zip through, well not zip through, but I'll go through these. A couple ones with the numbers. And then we'll pretty much be done for the day. Okay, so here I've got 6ax plus 12bx plus a plus 2b. Looking at this, I don't see anything in common across the board. That's always my first check. I always want to make sure there's not a GCF they all have in common, because if I don't take that out, I could be dealing with some big numbers, and I don't want to deal with big numbers. But it looks like you've got no coefficient on this one. So, and then this one doesn't have an A, those two don't have X's, and that one doesn't have a B. So that leaves no GCF across the board. Alright, so now I'll make two groups, the first group, the second group. And I'll deal only with the first group. 6ax breaks down into 2 times 3 times a times x. 12bx breaks down into 2 times 2 times 3, or 2 times 6, right? Times b times x. That's my prime factorization. Looks like they have a 2 in common, and a 3 in common, and an x in common. Alright, so GCF here would be 2 times 3 times x, or 6x. Once again, if you can see that, just go ahead and pull it out. But I'm breaking it down for those of us who maybe aren't as fluent in our factors, right? We kind of need to see, okay, what's the biggest thing 6 and 12 have in common? Oh, it's 6. Okay, cool. Alright, so 6x. Now I'll do the same thing for the other one. I have a plus 2b. Interesting. Well, no, hold on. Sorry, I didn't want to write it that way. I have a and a 2b. This one is an A, and this one is a 2 and a B. And interesting, this one doesn't seem to have anything in common still. Except what? What did we talk about? They always have something in common. A 1. So this one's GCF is 1. I'm not going to give up hope, just because, remember, there's always a GCF. So there should be no case where you can't do GCF 3 times. Okay. So now I'll go over here and I'll put them back together. If I take out a 6x from my first one, what's left over is an A and 2b's, or 2b, A plus 2b, right? If I take out a 1 from my other one, plus 1 times A plus 2b. Yes, I still have to take out the 1. Okay, I still have to take out the 1 because I need something left over when I do the third GCF. Okay, so now I've done GCF once, twice. Here comes my third time. Got 2a plus 2b in common, so a plus 2b comes out. And what's left over is 6x and a 1. And there is my final factored form. Fabulous. Okay, let's do another one. So here we've got 2k plus 2h plus jk plus jh, right? I can see across the board there's nothing in common, but it's always good to check. And since there isn't, I'm going to go ahead and start grouping. Here, the first one has a 2 in common. What's left over is k plus h. Here we have a j in common. What's left over is k plus h. And luckily they match. If they don't match, I probably did something wrong and I want to go back and double check. Because they match, I take it out and I've got my final factored form. So that one was pretty easy. Let's talk about this next one though. 24x cubed plus 18x squared plus 16x plus 12. That is, pretty standard. It's what we've been looking at. So let's take a look at it a little more closely. Do they have a GCF in common? Well, I might be tempted to just start grouping, right? Because it's 4 terms, and I can see the first 2 have something in common, which is great, but they actually have something in common across the board. They're all even, right? So I can take out a 2. I'm going to show you this problem in 2 ways. What happens when you do take out the GCF? What happens when you don't? Okay, because you can still arrive at the same answer if you forget the first step. But your life is going to be so much easier if you just start by taking out that 2. So if I take out a 2, I'm left with 12x cubed plus 9 x squared plus 8x plus 6. So I took out a 2 from everything, right? I know they don't have an x in common because the last one doesn't have an x, right? And I could break it down like we were before, but basically I see they have a 2 in common. So I took those out. Now I'm going to pretend like that 2 is not there, and I'm going to focus on this as a problem. And this one I know they don't have anything in common because that 9 is no longer even, right? So I'm going to just factor by grouping. Group the first 2, group the second 2. In the first 2, let's see, 12, well they have an x squared in common, I can see that. 12 and 9 both have a 3 in common. And when I factor that out, I get 4x plus 3. Alrighty, over here, 8 and 6, again, both even, so they have a 2 in common. What's left over is 4x plus 3. Alrighty, now they have a 4x plus 3 in common. So 3x squared plus 2 and 4x plus 3. Totally legal for me to write it in either order, right? The one they share in common can come first, or it can go second. That's just multiplication property. That's just, commutative property. But the last thing I want to do is drag and drop this 2. The 2 doesn't actually go away. He's just not used until the end, so I don't have to bother writing until the end. If you want to be super precise about it, you can say 2 and then put some brackets around this stuff. But you end up with this as a factored form. So 3 things in its factored form, which kind of makes sense because it's a cubic, right? It's got power 3, so when you break it down, you should get 3 things. Now let's see what happens when you don't take out that 2 to begin with. We've got my original problem, 24x cubed plus 18x squared plus 16x, oops, forgot the x plus 12. Alright, so let's just pretend I didn't notice that they were all even. I didn't notice they had a GCF amongst all 4 of them. And I just started grouping. Because for some reason I'm just like the biggest fan of grouping. Hugest is not a word. I'm the biggest fan of grouping, and I want to just do it all the time. So I will start doing it. 24 and 18, let's see, they have a 6 in common. And these both have an x squared in common. Right? So I'm left with 4x plus 3. So far looking good. Right, so far, looking good. Second term, 16x plus 12. Those guys have a 4 in common. I end up with 4x plus 3. Oh, hey, look, grouping is still working. Fabulous. Because I now have the same thing twice. Right, I have the same thing twice. So I can take that out, 4x plus 3, and 6x squared plus 4. And if you were just the biggest fan of grouping and you thought you were done, you might circle it and say, yay, I'm done. But that's impossible. Because you can't end up with 2 factored forms. You can end up with a negative version of a factored form, but these are 2 totally different things, right? You can't have 3 terms in one and 2 terms in the other. Each one has a unique factored form. So what's wrong with the second one? Well, take a look closely. This one, 4x plus 3, definitely prime. That one, not so prime, right? 6 and 4 still have something in common. 6 and 4 have 2 in common. So we still have this one. This one's nice and prime for us. But these guys have a GCF of 2. And when you take that out, get 3x squared plus 2, now you have the exact same thing. So if you do forget it, it's okay. Just don't forget to double check, okay? That's why you should just always start with GCF. Take those out to begin with. Then you have to deal with smaller numbers anyways, right? So then you'll get down to here. You don't have to worry about anything extra. If you don't, you might be inclined to pick the wrong answer because there's one there that's not prime. This is not an acceptable answer. This is the only true factored form. Okay, cool. Glad we talked about that. Now let's try, well, first let's do this first. So let's try this one. Let's see. I've got p squared, q squared, minus 10, minus 2q squared, plus 5p squared. I notice there isn't a p or q throughout, right? And there isn't a coefficient on the first one. So their GCF across the board is in fact 1. Okay, GCF is 1. That's fine. Okie dokie. Now let's try factoring by grouping. Okay, let's try this out. So I've got p squared, q squared minus 10. Well, nothing in common there. P squared, q squared minus 10. Over here, I've got 2q squared plus 5p squared. Nothing in common there. 2q squared plus 5p squared. Well, that sucked. Because nothing happened, right? I couldn't take anything out from either way. So what am I supposed to do there? That's a problem. Well, first off, let's get rid of this so that I can have some room over here. What am I supposed to do? Well, there's a little trick. You can try rearranging stuff. Let's use that commutative property. Commutative property says I can order this polynomial in any way I want, any way I so please. So let's try doing p squared q squared. Let's go plus 2q squared. Let's do plus 5p squared minus 10. So I've taken this 10 and I've moved it to the end and I moved everybody else up 1. That's what I did. Why? Just for the heck of it, because I thought that might be cool, right? Alright, so now let's try factoring by grouping and see what happens. So here, ooh, now they have a q squared in common. I can take out the q squared. I get p squared plus 2. Awesome possum. Let's go over here. Is there a typo in this problem? I think this should be a plus 10. Well, let's keep going. So I take out a 5. I can take out a plus 5p. Nope, no I can't. I can take out a 5. And I get p squared minus 2. Yeah, this should have been a plus 10. Sorry. Let's make that a plus 10. I will make that a plus 10 before I give you guys the notes in class. Okay, so plus 10. And I get p squared plus 2. Ah, now they match. Now they match. And I end up with q squared plus 5 times p squared plus 2. So don't think just because from the get-go it doesn't work, you can rearrange to find a factored form if you need to. That's when we end up with our final factored form. Sweet. Please don't go changing problems if one doesn't work. Only I could do that. Sorry. I wrote this problem, so really it's my fault it didn't work. But anyways, the point still stands. If it doesn't work the first time, rearrange it so that it does work. So there's sometimes you need to rearrange once or twice. Maybe it doesn't work at all. There are some that grouping doesn't work. Very, very low. Very, very rare. Okay, last thing we're going to talk about is factored form. What is factored form? We've talked about it once already with the example C. Factored form is the fully factored form. Again, names usually are what they are, right? Fully factored, meaning all the factors have been found. There are all primes. All prime polynomials. Okay, so there are no more GCFs anywhere. So let's take a look at this. Which one of these would be the factored form and why? Well, if we take a look at this first A is obviously not the factored form, right? Because it's all even. I could take a 2 out. In fact, those are all divisible by 4. I could take the 4 out. So it's not A, right? Because that wouldn't be my factored form. This might be my factored form. It might be, right? Because I took the 4 out and there's nothing left, right? This one doesn't have an X. Sorry, this one doesn't have an X and this one doesn't have a coefficient. So that could very well be my factored form. But it's not. because I can GCF that bad boy. Or I can group this bad boy. This guy I can do grouping on, and it would work. I noticed these two guys have something in common. These two guys have something in common. GCF would definitely work, or grouping would definitely work here. So it's definitely not B. Go taking a look at C. Well, this one looks very, very much like the answers we've been getting, the kind of answers, but what's the problem here? This one is prime, this one is not, right? I can take a 4 out of there. And so let's take a look at this one. That one is definitely the factored form, mostly by process of elimination. But here I've got 4 standalone. Clearly you can't have a GCF by yourself. Here, x and 16, right? That's definitely prime because they have nothing in common. Same goes for x plus 3. That's our factored form. So make sure, it's very, very important that you take things all the way down to factored form. If you don't, you have not achieved the right answer, okay? If you leave stuff like C here, or even like B here, then you are not even halfway done, okay? You need to finish it. You need to finish it out until you get all of the factors, just like prime factorization, okay? You can't just leave this one as, or you can't just leave 20 as 4 times 5. That doesn't help you. You want all the way down to factored form. Okay, cool. So that's 6.1. That's about grouping and GCF. Like I said, this is probably, GCF is probably the most important. You can see how much grouping uses it, but GCF is the most important subject for this chapter. So now you may start your homework, or go back to your homework if you're using this as a supplement video. Otherwise, email me with questions, and I will see you next time.